All right, guys, today I want to finish up our direct variation notes. So we were working on page 53 last time. We're going to do 54. So on page 54, we want to remind ourselves about direct variation, which is basically the equation y equals k times x, where the k as a letter kind of doesn't matter. Like, really, it's just m, and really it's just slope. So it's kind of like m. It's kind of like slope. We just call it a constant of variation. When there's no additional number being added or subtracted after that. So a direct variation graph will always go through 0. So it'll always go through the point 0, 0. And that's what makes it directly varying with x and y. So one really good example of that is if they tell me that if y is 16 when x is 4, find x when y is 32, well, their ratio will always be the same. And so when I write k on its own, or when I want to find the ratio of slope or the rate of change, k really turns into like if I were to solve for k here, I would divide x on both sides. So y over x. It will be the same for any point on the line, any spot on the line. So for this one here, I know that y is 16 when x is 4, and that needs to be the same as whatever x is when y is 32. So y would still go on top, and x, this x I do not know. So we can use cross multiplication to solve. So, or I could reduce and solve, honestly, like that divides by 4, and so I divide that by 4. Or if I look here, I times by 2, so I'd also have to times by 2 here. Lots of different ways we can do it. The most straightforward, I think, is to cross multiply. So we'd have 4 times 32 is going to be equal to 16 times x. And then I need to divide 16 on both sides. And any way you go about it, you're going to get that x is 8 when y is 32. Now, I could also write the equation for this, because when I do 16 divided by 4, or when I do 32 divided by 8, or when I do any y value on this line divided by any x value, I'm always going to get the ratio of 4. So that means that 4 is my slope. And so I could write the equation y equals 4x to represent this direct variation equation. So that's also kind of a fun way to do it. Now, speaking of equations, if I know that I have these direct variation equations here, first of all, I know that they are because there is no number being added or subtracted at the end. So these only have slopes. And so no matter what, they will always start at 0, 0. Like a direct variation equation will always go through 0, 0. So that gets me a really nice starting point. And then I could think of slope as rise over run. So probably the easiest one to look at is this one here. I can clearly see that the rise value is 2 and the run value is 3. So if I start here and I rise 2 and then run 3 in the positive direction, I can plot another point. If I have 2 points, then I can draw a line. And this line will go on forever. Now, the really nice thing is I could also go backwards and get a point. So if I do both of these numbers negative, a negative divided by a negative is a positive, and so I still have positive 2/3. So I could also go down 2, back 3, and that's another point on my line. I didn't do a super good job, but it is a point on my line. So with this one here, this one is a little bit sneakier because it's not written as a fraction, but I can always put it over 1. And so now I can see my rise and run. I'm supposed to rise, -2, really go down 2, boop, boop, and then run, +1. And as long as I have 2 points, I can draw a line. And boom, there you go. Okay. Decimals don't like them. 0.5 is really half. And I like that better because now I can see my rise and run. So again, I start at 0. My rise is showing me that I'm going to go up 1 and then positively 2. Or if I go back to the starting point, what I could have done instead is down 1 and back 2, negatively 2. And so then you have more points that you could draw. And then the last one that I have for you on the front here is negative 3/4. Now, when my slope is negative and a fraction, I have to assign that negative to either the 3 or the 4, not to both. So if that negative is going to go with the 3, that's fine. We started our starting point of 0, and then I'm going to go down 3, and then positively 4. 1, 2, 3, 4. Now I could do it again, but it wouldn't fit on the line. So I could also go 1, 2, 3 up, and then backwards 4. 1, 2, 3, 4. And there you go. And again, you want to make sure that all your slopes make sense. So that was a negative slope, and this is a going down line, so that makes sense. This was a positive slope, and it's going up. This one hopefully was a negative slope, and it is. And this is a positive line going up, and it's a positive slope, so that's super good. Now, if we kind of try a couple of these in here, the y value is negative 3 times the value of x. So the y value is negative 3 times the value of x. Oh, so that's telling me my equation has to be y equals negative 3x. So I could go and make a table where I know 0, 0 is a spot. And because it's not a fraction, I can pick any x's I want. So I'm going to pick some negative x's, negative 1, negative 2, and some positive x's. And really, we're just timesing by negative 3. So negative 2 times negative 3 is 6. 3, 0, negative 3, negative 6. And then we could plot all those points. But like, I don't know, it's kind of easier just to be like, okay, that slope is negative 3. I'm going to go down 3, positively 1, which is what happened because at 1, I'm at negative 3. And I can't even fit the 2 comma negative 6 on here, so whatever. And then same thing here, negative 1 is up at 3, but I can also see that my slope is down 3 over 1. So I don't know, if you just like doing slope as rise over run, why would you even make a table, is what I'm saying. Another example could be a little bit more like real lifey. So the total cost C of gas is $3 times the number of gallons that I get. Ooh, that's expensive. It used to be that much. So C equals 3 times G. So very similar to the last one, although with this one, because it's talking about a real life scenario, I don't think it makes as much sense to pick negative numbers here because I'm going to pick the number of gallons of gas I would get, and I can't get negative gallons. I suppose I could get 0 gallons of gas, and it would cost me $0. And if I get 1 gallon, it'll be $3, and 2 will be 6, and 3 will be $9. So it's just going up by 3 every time, which I can see that as my slope. And I can also plot my graph 0, 0, 1, 3, 2, 6. And you can also see that as slope on here because I went up 3 over 1, up 3 over 1, up 3 over 1. But again, because it's kind of talking about a real life scenario, I don't know that it makes sense for us to draw an arrow going negatively because we can't buy negative amounts of gas. So yeah. Next, the y value is 2/5 times the value of x. And then the total cost C of bulk jelly beans is $2.50 times the number of pounds P. I'm going to leave these two to maybe try with you guys in class. So we'll leave it at that. The only other thing I might add to your notes is like a little title on here. Like maybe we'll just add direct variation. Examples. And maybe we'll add something on the front of that too in class, but we'll leave it at that for this video for today.